So this is talking about acids and bases. So what we've got sulfur is a yellow crystalline non-metallic element, and it can combine with other things to form compounds. Okay. So we've got magnesium sulfate, we've got hydrogen sulfide, and sodium sulfide. Okay. Note the difference between sulfide and sulfate. Yeah. So sulfide is just that S2 minus you'd get straight from the periodic table, whereas the sulfate is that combination with extra oxygen. Okay. To give you an SO4 and it'd be a 2 minus charge. Suggest reactants that could be used to produce an aqueous solution of the salt magnesium sulfate. So hopefully remember your equations for making salts. So we can have metal, which would be this one, we can have metal hydroxide, we can have metal carbonate or metal oxide. All of those things you would be able to react to give you the magnesium bit on the front of the salt. Okay, and then afterwards you would have the sulfuric acid bit would give you the sulfate. Okay, so you need 1 mark for each. State the names of any other products that are formed in the reaction that you've described. So depending which one you picked, if you chose a magnesium metal, you would get a salt plus hydrogen. So all these ones here, they're this is just where you'd have salt, and the salt would obviously be the magnesium sulfate. So magnesium makes hydrogen as a byproduct. Magnesium oxide and magnesium hydroxide would both make water, and magnesium carbonate would make carbon dioxide and water. An alkali is a base dissolved in water. A student investigates the reaction of 4 oxides with acids and alkalis, which shows below. So he correctly classifies sulfur dioxide as an acidic oxide, okay, because this is a non-metal, okay, and he also says it reacts with alkalis. Complete the table. So basically, what have we got in here? We've got non-metal oxides make acids, okay. Metal oxides will make alkalis because they react with acids, so basic or alkaline for that middle one. Okay. Aluminium oxide says it reacts with both. So that's the term that's in there. It doesn't come up very often, but be careful because it is in the notes and in the spec. Okay. It's amphoteric. What it means is it'll react with both. Okay. And the opposite of that obviously is something that will react with neither. Yeah. So if it's neither, that means it's just going to be a neutral oxide. Okay. So nitrous oxide is an example of that, where it doesn't produce an acid or an alkali. Figure 9.1 shows some apparatus. They put in some sodium metal into water, and then they're going to measure the pH. Okay, so what's going to happen to the pH? Well, as the sodium reacts, hydrogen is going to be given off. Sodium hydroxide produced under here. Okay, sodium hydroxide is an alkali. Therefore, the pH is going to go up, and it's going to be greater than 7, probably along the lines of towards pH 14. Okay. So write the balanced equation. So we've got sodium metal plus H2O goes to give sodium hydroxide. So it's Na is single plus, OH is single minus. Then it makes hydrogen gas, H2. You must remember to remember your diatomic elements. So that have no fear of ice cold beer mnemonic to help you remember which elements are diatomic, because otherwise if you put a single H there, that means your formula is correct, so you lose the mark, but it also means then you're not going to be able to balance it properly. Okay, so it should have a H2 here, which means then you've now got 2 hydrogens here, and you're going to have 1 as part of this. Okay, so we need 2 sodiums on both sides. Okay, so now I've got 2 hydrogens here, and I'm going to have 1, 2, 3, 4. I need to finish this off because I haven't finished it. Okay, so if we look on there, now I've got 1, 2, 3, 4 hydrogens on the left, and 1, 2 hydrogens, 3, 4 hydrogens on the right. Okay, 2 sodiums and 2 oxygens. So that balances up. Okay. Hydrogen chloride gas dissolves in water to form dilute hydrochloric acid. Describe the effect of dilute hydrochloric acid on litmus paper. So litmus paper, you get either blue or you get pink. Sometimes we call it red. But the idea is that either the litmus paper will, if it's blue, it's going to go pink or red. And if it's already pink or red, it's going to stay pink or red. It's not going to go blue. Okay. Circle the formula of the ion present in all acids. My circle appears to have moved. It should be a hydrogen ion. Okay. So this is the one that's present in all acids. This one would be an alkali, the OH minus, and these two really does depend on what's going on. Okay. A technician has run out of an insoluble salt, lead chloride. He's got a good supply of salts below. He prepares a precipitate of lead chloride by reacting lead nitrate and sodium chloride. Explain why he chooses these salts. Okay, So what did he choose? He chose lead chloride. Sorry, lead nitrate, that one there, and sodium chloride. So if you remember, all nitrates are soluble, and all group 1 are soluble. Okay, so both of those are soluble, but also they will provide the required ions that you need. So you get lead 2+ from this one, and you'd also end up with your Cl- ions from the chloride for the other one. Okay, right, the word equation for this, well, all you're doing is double displacement. So you've got lead nitrate and sodium chloride, and they're just switching places, aren't they? So the lead comes over, joins with the chloride, lead chloride, and the other one left would be sodium nitrate, which would be the one left over. So actually, this one here would be aqueous, and this one here would be our precipitate because it's insoluble. So we'd be able to filter that out, and we've done about that in the past. Okay.